Hi, everyone. I wanted to go through the initial setup of PrusaSlicer. I think it makes sense at this point for us to slice all jobs for our Prusa printers on this platform rather than Cura. So it's really important that we make sure that it is set up for our printers and our filament. So I'm just going to walk you through that, and then I'll follow it up with a brief overview of this slicer. Those of you that are familiar with Cura, I imagine you'll eventually be able to find your way around, but I just wanted to go over a few basics. Generally speaking, this is very user-friendly, and the results are, I think in every case, better when you slice a model on PrusaSlicer versus Cura. I don't see many advantages at this point with staying with Cura. So to start with, the first time you launch PrusaSlicer, or if you've already started to use it, you may have already gone through some of these steps, but I'm just going to start at 0. When you launch PrusaSlicer for the first time, and by the way, this is version 2.6. 2.6 is important because it is the first release that has the organic tree supports. So it's a new type of support option, new type of support structure, removable support structure that is pretty minimal, is reasonably easy to remove, and doesn't leave a lot of residue, if any. So the finished product is great, and it's easy to remove, and it seems to use less material. So that's, as far as I'm concerned, there's not many downsides. I just haven't tested it much, but I can show you a little bit of that support in a little bit. To start with, we want to make sure that the slicer is configured properly. So if you go to configuration wizard, we don't need to update the profiles at this point. So the first thing, welcome to PrusaSlicer. Let's continue. Very important, we need to select the printers that will be available for us to slice for. So we have 2 printer types from Prusa currently. We have the Mark IV with the 0.4 millimeter nozzle, so I have that selected. And then I'm going to scroll down to the Mark III family, where we have the Mark III S Plus, also a 0.4 millimeter nozzle. In the future, if we experiment with different nozzle diameters, we could add different profiles. But for now, those are the only 2 filament printers we want to add. It's that simple. Then we go next. We'll cycle through those, cycle through this. Custom printer setup, not necessary. And then we get to the filament profile selection. So we do want to specify this, okay? The vendor that we use for our filament, default filament, is Overture, and the only option is to choose Overture PLA, so we'll go ahead and do that. Automatic updates, that's fine, that's fine, that's fine. File association, we can set this up so that STL files on the workstation automatically launch PrusaSlicer. I think that's a safe thing to do. And then finally, view mode. I'm going to say we should default to advanced. Simple doesn't offer quite enough variability, and expert, I don't know that we need all of that. So let's start. You can switch these in the software, but for now, let's start with advanced by default. And then finally at the bottom, it allows us to add inches as a unit to work with. So you still have the choice of working in millimeters, but by adding inches, it gives us a little more flexibility. So go ahead and check use inches, and then we can finish. Okay, so we've set up our printers and our material. So one last thing, if you go to the top here, there's filament settings, and we want to add the cost in spool weight, so it will calculate the costs for us. So under cost, we want this to be 50, and then under spool weight, we want this to be 1,000, okay? Actually, before we do that, I'm sorry, it was defaulting to the ABS. So under the drop down, let's make sure we're choosing Overture PLA. And I'm going to discard those changes to the ABS. So once we have Overture PLA selected, now we can go in and update the cost and the weight. Again, it's 50 for cost, 1,000 for spool load. Once you've made those changes, you can go up to this icon and save preset, and we can name it whatever we want. We'll just keep it Overture PLA copy. So now it saves those values in the Overture PLA profile for the Mark III printer, because that's what it's currently pointing to. So if we switch over to the Mark IV and we go to filament settings, you notice it's different. So we do want to go ahead under filament settings, Overture PLA, and update that as well on this side. So you have to do it for both printers, and again, save the preset. So once a preset is created, right, these are the system presets here. Once you create your own preset for the Overture material that has the cost and the weight attached to it, you should be set, right? So if I go back to my printer settings tab and go in and select the Mark III instead. Okay, when I go back to filament settings, I have to still go to the drop down and choose Overture PLA. So kind of a wonky way that works, but you have to ensure that when you slice a part, you're getting a cost estimate. You'll have to make sure the cost and weight are set properly. Okay. So let's keep it in Mark III for now, and the filament settings are correct. Let's look at print settings in the tabs. And this is, if you remember, we're using the advanced settings. So on the top right here, at any time, you can select between the three settings. If you look at simple, it reduces many of your options. And I've found that advanced makes available some options that I think we may be interested in. That's why I say start with advanced. We won't touch on this immediately. We'll move over to the plater. So the plater is really where you'll be doing most of the work, right? The plater is, I'll move my window out of the way here. That's where you're going to set up your drag and drop your file in, similar to Cura. And again, even the number of tools that are available here for you to manipulate the geometry will vary depending on which setting you use. And advanced gives us a few more tools to play around with. So with that in mind, we have our plate, we have our benchy sitting here, and let's just go through some of the tools to manipulate and modify the part. We have move, straightforward enough. Scale, again, these are all straightforward. Rotate. Lie flat is its own tool, or place on face. And I really like this because it will kind of give you a hint to the general face of different areas of the part. If you just left click on it, it reorients right away. And you know, the obvious thing is there's the bottom face. If we just left click it, it'll reorient to the plate. So that's a really quick way to make sure that the part is actually sitting flat on the bed. If we pre-select the part again, let's see, we have cut. Cut's pretty interesting. This allows us, if I just hold the left mouse button down, I can basically move this up and down. I can also rotate in any orientation or any position, and cut, split, and move those two parts to be flat on the bed. So this is a way within PrusaSlicer to trim a model that's, say, too big or maybe too complex or not appropriate to be printed, and you can split it more than once to lay out on the bed. So I found this to be pretty interesting. So if I just take it halfway roughly, you can also look at the cut position here, which is a z-value. You can key in, you know, any number you want. And oh, by the way, like 1 is in 1 inch. So if you look at the bottom right of the screen, there's a toggle for inches and millimeters. So if I deselect inches, it will move over, it just defaults to millimeters. So I'll use millimeters for this. Point. There we go. Okay, so I'm going to say I want my cut position to be at a Z value of 20 millimeters. And you can choose, you know, what happens to the individual pieces, whether they get flipped or they get placed on the cut and that sort of thing. Let's just go ahead and perform cut and splits them in two. It's still one selection, which is interesting. So I think there's a way. Oh, there we go. They were just both selected. So, right. Just a good tool for breaking down a large part. Okay. Moving it down, the next tool that could be useful is what's called paint on supports. So if we select this, you can actually just move on right up to the part and click and drag and flip. And literally kind of brush on areas that you want the support to happen, right? So if I just have those three stripes, I'm just going to go ahead and slice because I want to see what this gives us. By the way, the slice is in the bottom right hand corner. Oh, I don't have support on yet. So I'll go ahead and turn this on, set it to everywhere and slice it. And there we go. I don't know that that gave me what I was looking for actually. So let's go towards grid. For some reason that's not behaving the way it should. It should really generate supports in those key areas. Well, that's something I'm still experimenting with, but I think this may be really useful for certain cases where it's obvious a part has an overhang that needs to be supported, but maybe the rest of the model doesn't need anything, or more importantly, you don't want support elsewhere, even if it's generating it automatically. Maybe you know the part's just fine without it. So I think this could be really advantageous for certain kinds of geometry. Let's move back to, I'll go ahead and move back to the move tool. So a few other things just to get bearings, the slices in the lower right-hand corner. The top right is where you can choose to turn support on or off. You can also set it so that it only generates support from the build plate up to the model, not between pieces or not between surfaces of the geometry itself, of the model itself. I usually just set it to everywhere. In the print setting, I've defaulted to is the 0.2 layer height, which is what we should normally be using, and quality. So I think that's a good combination of efficient printing and high quality prints. But if we go to print settings, so actually under the plater, if I just, maybe I can rebuild my bench sheet. I want it to split. So there's our bench sheet. With support turned on, let's go ahead and slice it so we can look at the results. And this, by the way, is with the kind of standard support, which does look a little different than Cura. That seems to perform well, tears off easily, but it's pretty well surrounding the entire part, right? And this bench is maybe not the best example, but let's look at under print settings where we can adjust the type of support material. So that was using what's called grid. There's also snug and then organic. The one we're interested in is organic. So let's switch back and see what that gives us. So again, I don't know if this is the best example to demonstrate how this works, but you can see it's definitely wild. It is more efficient generally. In this case, I'm not sure. I didn't really compare. Let's check the material usage of the other type of support. But you can see this is much easier to get into and rip off. And I think that's one of the advantages. It's also surprisingly stable for a tree support, right, for a branching structure. So while I imagine it uses less material in some cases, it's extremely rigid. Now let's just check. So it says used filaments, 18 grams. So let's switch back to the grid just out of curiosity. 18 grams, it's about the same. And the run time is 2 hours, 12 minutes. I would say if it's the same run time, I would use the organic support every time. 2 hours, 20, so it's like 15 minutes longer. So it does take a little longer, but I feel it's so much easier to deal with. And it may be really depend on the type of part, you know, in some cases this might not be the right move, but I think I would encourage everyone to start using it, experiment with it and see how it goes. Okay, so I'm not going to get into any of the print settings yet, but in the lower left, you can toggle between the STL view and the slice view, right? And in the lower right, as I was looking at earlier, you can get an idea of the amount of material used. And if you did set up the filament correctly, so under filament settings, the cost and weight, cost is 50, the weight is 1,000. Over here, we'll see that the cost estimate is correct. It's 91 cents, right? To export, just remember when you're saving the G code, before you save it to an SD card or a USB thumb drive for the Prusas, first save it to the Prusa G code folder, right? So just as a refresher, that's located, no, not there. It's located in the FAB Lab folder under 3D printing, Prusa, and then Prusa G code files, right? Save the file here. And then you can turn around and point to, you know, your SD card or your USB. But we always need it saved to the network as well, so we can find the file down the road. Okay, I think that does it. I think this will help everyone get started. If you haven't used PrusaSlicer yet, please do. Please get familiar with it because I want all Prusas to be running PrusaSlicer from now on. Okay. If you have any questions, just let me know.